A very warm welcome, students, in the another session of mathematics. Today I am going to start a new chapter, Quadrilaterals. Hope everybody has gone through the animated video of chapter Quadrilaterals that I shared on 22nd July. If you have not, then please go through that video for the better understanding of the concept of chapter Quadrilaterals. What a quadrilateral means. A plane figure bounded by four line segments is called a quadrilateral. Very important to know what is a plane figure. The figures which can be drawn on a plane, that is on a paper, or the figures which have only two dimensions, those figures are known as plane figures. Closed figures, that means all the line segments should be joined at somewhere. It should not be open at any end, and it should have a four line segment. If a plain closed figure has a three line segments, then it will become a triangle. If a plain closed figure has a five line segments, it will become a pentagon. So as here we are discussing quadrilaterals, so we are talking about those figures which are bounded by four line segments, and they are plain as well as closed. So I have drawn a quadrilateral here. I named it as PQRS. Now we'll discuss the number of vertices and the sides and the angles a quadrilateral has. If you go through the vertices, how many vertices it has? Vertices means where the two sides meet at a point are known as vertices. So a quadrilateral has how many vertices? It is 4. How many sides it has? PQ, QR, RS and SP or PS. These are the four sides of a quadrilateral. So it has 4 sides. How many interior angles? If I am saying angles, that means we are talking about the interior angles. How many interior angles a triangle has? This is 1, this is 2, 3 and 4. So a quadrilateral has 4 interior angles. Then we talk about the opposite sides. Opposite sides means those sides which do not have any endpoint in common. If we talk about PQ and RS, do they have any endpoint in common? PQ has two endpoints, that is P and Q. RS has two endpoints, that is R and S. So as they do not have any endpoint common, therefore the two sides are opposite side. If I say PQ and QR, so PQ and QR have a common endpoint, that is Q, so therefore these two are not the opposite sides. If I say PS and QR, so PS and QR also do not have any endpoint in common, therefore the two sides are known as opposite sides. So if I say to write a pair of opposite sides, then it is PS and QR as well as PQ and RS. Then we talk about adjacent sides. The sides which have a one endpoint common are known as adjacent sides. As we have PQ and QR, they have a common endpoint, that is Q. Therefore, PQ and QR are adjacent. If we say PQR and RS, they have an R as a endpoint common to them, so these are the two adjacent sides. Similarly, RS and PS are adjacent sides. PS and PQ are also adjacent sides. So if we ask you to write a pair of adjacent sides, then it becomes PQ, QR, QR and RS, RS and PS, PS and PQ. Then very important to remember the sum of all the angles of a quadrilateral. If again we are saying all the angles, then means we are talking about all the interior angles of a quadrilateral. The sum of all the interior angles of a quadrilateral is 360 degree. Let's see how. I draw a quadrilateral here. Now I join the two I name it as A, B, C and D. Now I join the two opposite vertices of this quadrilateral. I join A with C. Now the quadrilateral has been divided into two parts, that is triangle ABC and ADC. We know the sum of all the interior angles of a triangle is 180. Similarly, the another triangle, that is ADC, the sum of all interior angles of this triangle is also 180 degree. Now if we add both, see again this angle B, if we consider quadrilateral ABCD, this angle A is comprised of these two parts, angle B we have, angle C again has two parts, and angle D. If we sum all these interior angles, then we'll get the sum of all the interior angles of our quadrilaterals. So if we add them, it will become 180 plus 180, so that becomes 360. Therefore the sum of angles of in quadrilateral is 360 degree. It's an important note. So when you are now going to start with the exercise 17A in your fair copy, firstly, you are going to write the definition of a quadrilateral. You are going to draw a diagram of a quadrilateral, and then important to write this point that the sum of angles of a quadrilateral is 360 degree. You can skip writing the opposite sides and adjacent side, but you need to mention quadrilateral, number of vertices, sides and angle, and this important property of a quadrilateral. So now we proceed with exercise 17A. We come to exercise 17A, question number 1. The three angles of a quadrilateral are 68, 74 and 108. Find the measure of the fourth angle. So we are going to apply this important rule that the sum of angles of a quadrilateral is 360. As three angles are given, we can find the fourth angle very easily. Then question number 2, the angles of a quadrilateral in the ratio of 4:3:2:6. Find the measure of each angle. So how we are going to do? We let the common factor be x, and then we'll write all the four angles. That becomes 4x, 3x, 2x and 6x, and then we'll sum up all, and that sum will be equal to 360 degree. So you can find the measure of each angle very easily. Student, question number 3 is of the same type. I do question number 4 for you. The two angles of a quadrilateral are 72 degree and 56 degree respectively, and the remaining two angles are in the ratio of 3:5. Find the measure of each angle of a quadrilateral. Let's see how we do it in the copy. Now we do question number 4. First, angle 1 is given equal to 72 degree. Angle 1 is equal to 72 degree. Angle 2 is given to you is equal to 56 degree. This is given. Now we let the common factor be x. Let the common factor be x. Therefore, angle 3 is equal to, will become, the ratio of the remaining two angles is 3:5. Therefore, angle 3 becomes 3x and angle 4 becomes 5x. Okay. Then we write angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360 degree. Then we'll substitute the value of angle 1, angle 2, 3 and 4. So this will become 6 and 2, 8, 7 and 5 becomes 12. 3x and 5x will become 8x is equal to 360 degree. 8x is equal to 360 minus 128. X is equal to 360 minus 128 will give you 10 minus 8 will give you 2. 5 left here. 5 minus 2 will give you 3. 3 minus 1 will give you 2. So that becomes 232 x upon 8 because we are looking for the value of x. Now we divided with 8. 8 3s is 24 which is greater. So 8 2s are 16. We cancel it out. 8 2s is 16. And when we are left with 16, we are left with 72. 8 9s is 72. So the value of x is 29. Now we calculate angle, the remaining two angles, that is angle 3. Angle 3 is equal to 3x. So that becomes 3 into 29. That will give you 7 9s, 3 9s is 27 and 2, 3 to 6, 7, 8. 87 degree. And angle 4 will become 5x. So 5 into 29. 5 8 is 5 9 is 45. 4 carry, 5 to the 10 and 14. So this way we have calculated the remaining two angles of the quadrilateral. Now I discuss question number 5 with you. The two angles of a quadrilateral are 116 and 84 degree. Find the remaining two angles. The remaining two angles are equal. What is the measure of each equal angle? So let the each equal angle measures x. So 116 plus 84 plus x is equal to 360 degree, and you will be able to get the value of x. So exercise 7a up to question number 7, it is very easy. You can do all the questions of your own easily. If you find any difficulty, you can send me the query. Similarly, you can do question number 6 and 7. Now I discuss question number 8 with you. In a quadrilateral ABCD, it is given that AB is parallel to DC. The ratio of angle A and D and the ratio of angle B and C is given. We are looking for the measure of each angle of a quadrilateral. Let's see how to do. Now I proceed with question number 8. So ABCD is a trapezium. The ratio of angle A and D is given. Ratio of angle B and C given. The moment these two lines are parallel, we need to remember the properties of parallel line, children. Parallel line, these two angles are co-interior angles, and we remember the sum of co-interior angles or the allied angles is 180 degree. So if we check with this figure, angle A and angle D, if we extend these two parallel lines, angle A and angle D are forming the interior angles, co-interior angles or allied angles. Therefore, the sum of angle A and angle D will be 180. Similarly, angle B and C are also, if you extend the lines, angle B and angle C are also forming co-interior angles. Their sum is also 180 degree. So how we write it? Let common factor be x. Therefore, angle A is equal to 2x. Angle D is equal to 3x. Then we'll write angle A plus angle D is equal to 180 degree. Reason we have to mention in geometry. So we'll write co-interior angles. Angle A is 2x, angle D is 3x. That is equal to 180 degree. Therefore, 5x is equal to 180. x is equal to 180 by 5. That will give you 5 3s is 15, 3 left, 5 6s 36. So the value of x is 36. Therefore angle A is equal to 2x is equal to 2 into 36 degree. That becomes 72 degree. Angle D is equal to 3x. So it becomes 3 into 36. That becomes 6 is 18 and 1 3 is 9 and 10. That becomes 108 degree. So this way we have calculated the angle A and angle T. Similarly, we calculate the value of angle B and angle C. So what we write here? Now we cannot let the common factor be x. We have already let it. So let the common factor be k. Let the common factor be k. Therefore angle B is equal to 4k. Angle C is equal to 5k. Then again we'll write angle B plus angle C is equal to 180 degree. We need to mention the reason, so I write co-interior angles. Now I put the value of B, that is 4k, value of 5c, value of C, that is 5k. So that becomes 180. 9k is equal to 180 degree. K is equal to 180 by 9. That becomes 20 degree. Therefore angle B is equal to 4k. So that becomes 4 into 20. That becomes 80 degree. Angle C is equal to 5k. So that becomes 5 into 20. That becomes 100 degree. So this way we have calculated all the 4 angles of a trapezium. Now I discuss question number 9 with you. In the adjoining figure, the side BA and DC of a quadrilateral ABCD have been produced to E and F. So if DC is produced up to F and BA is produced up to E, prove that A plus B is equal to X plus Y, where angle D measures Y degree, angle B measures X degree, and angle B is the exterior angle of, and angle A is also an exterior angle here. So let's see how to do it. We do question number 9 now. Angle A plus this angle are forming the linear pair. Therefore, this measurement of this angle will become 180 minus A degree. Similarly, B and this interior angles are forming a linear pair. Therefore, the measurement of interior angle will become 180 minus B degree. So, I write that firstly. To prove A plus B is equal to X plus Y, given ABCD is a quadrilateral. So now I am writing the proof. First you write B degree plus angle A, that is angle DAB plus angle DAB is equal to 180 degree. Reason need to be mentioned every time. So this is forming a linear pair. Therefore, angle DAB is equal to 180 minus B degree. Similarly, angle BCD plus A degree is equal to 180 degree. Reason need to be mentioned, linear pair. Therefore, angle BCD is equal to 180 minus a degree. Okay, now we are showing that a plus b is equal to x plus y. For that, what we take, it is given that ABCD is a quadrilateral, and as we are given with the angles also, so we use the property that the sum of angles of a quadrilateral is 180 degree, and we sum up all. So we write angle A plus angle B. So we'll write first in quadrilateral ABCD. Angle A plus angle B plus angle C plus angle D is equal to 360. Reason, sum of angle of quadrilateral. Okay. Angle A is equal to, we calculated above, is 180 minus B. Angle B is x degree. Angle C we calculated above, that is equal to 180 minus A, plus angle D. Angle D is equal to y degree. So that is equal to 360. 180 plus 180 will give you 360 minus A minus B plus x plus y is equal to 360 degree. Now we transpose 360 and minus A and minus B to the right side, and we keep x and y on the left side. So what you will get? 360 minus 360, this minus A on that side will become plus A, and this will become plus B. So this way 360 gets cancelled. We are left with x degree plus y degree is equal to a degree plus b degree. This we were supposed to prove. Now I discuss question number 10 with you all. If O is a point within a quadrilateral ABCD, prove that OA plus OB plus OC plus OD is greater than AC plus BD. For that, what we will do, first I consider triangle AOC, this follow triangle. We know OA plus OC is greater than AC. We'll apply the property of inequality of triangles. In a triangle, the sum of two sides is greater than the third side. Then I'll consider triangle DOB, OD plus OB will also greater than BD, and then we'll sum up these two inequalities and we'll get the solution. So let's see how we do it in a copy. I said firstly we are going to consider triangle AO and C. So I write, to prove OA plus OB plus OC plus OD is greater than AC plus BD. This we have to prove. For that, what we consider? Firstly, I am going to consider triangle AOC. We'll write OA plus OC is greater than AC, the third side. Reason need to be mentioned. Sum of two sides is greater than, of a triangle is greater than the third side. Then we consider another triangle, that is DO and B. So now we consider triangle DOB, OB plus OD is greater than BD. This is the first inequation. This is the second equation, inequation. The reason is same for both. Now we'll add first and second inequation. So what you will get on addition? OA plus OB plus OC plus OD is greater than AC plus PT. So this way we have completed with the solution of question number 10. So do complete all the questions of exercise 17A. All the questions we are going to complete in the fair copy. Before we start with the questions, we need to mention about quadrilaterals, figure of a quadrilateral, number of vertices, sides and angles, and this important property in the fair copy. Then we'll proceed with exercise 17A. If you have any query, you can send it to me. That's the end of the session. Have a good day, children.